Hi, my name is Jen, and today I'm going to tell you about some horror stories that I've experienced with testing and QA and how you can avoid those yourself. So I work at Elsevier in the precision medicine department. Elsevier is a 200-year-old company with their headquarters right here in Amsterdam. And while testing is important no matter what industry you're in the healthcare side of things, we use it not only to make sure that our features work, but also for auditing and compliance. So who here has heard of Tales from the Crypt? I imagine not too many people. OK, good. Quite a bit. Tales from the Crypt was a show from the 80s and 90s. And this here is the crypt keeper who was the host of the show. And they would tell you horror stories every week. Today, I will be your crypt keeper. And this show was also based on comics from the 50s and 60s. And I'm going to show you some of those comic book covers today as well. So our first story that we're going to cover is manual testing. Let's take this example of an email address input. Most of us have this on our site somewhere for login or sign up. And if you want to test this in end-to-end testing, what you would have to do if you were doing this manually is enter each one of these things to make sure that you can enter a valid email address every single time. So there's about 13 different lines here. I would imagine that this would probably take 2 or 3 minutes if you were typing all these things in manually. And then you also have to make sure that these things don't work, because you don't want people to put invalid input into this field. So let's double that time just to make sure that this one field works on your site. So let's step back for a moment and talk about the traditional QA model or testing model that I've worked with many teams. You typically have a QA lead or a quality assurance lead that works with a dev team, so a bunch of developers, and that QA person is the liaison to other testers. And there's no overlap between the developers and the testers themselves. And I've always been kind of confused of what this separation is for. Sometimes those testers may be offshore, so there's a time difference. But I've always thought it was weird that I never got to interact with these people directly. So what happens when you have this type of workflow is that you get stuck in this repetitive flow. A tester tests a feature. If it doesn't work properly, then it has to go up to the QA lead. They have to test it and make sure that it can be replicated. And then it goes up to the developer, who has to do the same thing again. And then they have to fix it, and the cycle repeats itself. So when you have something that's a long checkout form and you want to make sure that it works perfectly every time, and you're entering everything in all of these fields, it can get scary pretty quick. Luckily, there have been automated testing tools around for quite some time. Slimer, Casper, Nightwatch, and Nightmare, a lot of these depend on Selenium. A tool that I really like and I've been using lately is called Cypress, and I'm going to do a live demo of that today. Cypress is different because it comes with everything that you need out of the box. And you can install it with one command, whereas other frameworks, you need to install Selenium. You might want to choose a wrapper and additional libraries. But with Cypress, all you have to do is npm install, and you're done. And if you're writing JavaScript or you're writing single-page apps, it makes sense to write your tests in JavaScript as well. And then you can open Cypress with a single command as well. And you can run your tests headlessly or in the browser on your machine. So this is what a simple page load test might look like. We're just loading a page and checking that a CSS selector exists on that page. This is as simple as you can get. So let's take a look at our demo. So I've created a demo site for this talk. It's a simple to-do app, because we all know how these are supposed to work. You should be able to add something, mark it complete, see what's still active, see what's completed, and also delete things as well. So let's take a look at what this looks like when we run Cypress. So Cypress will open up a little UI for you, which is really nice. Before we run those tests, let's take a look at what that actually looks like, because I think it's pretty readable and easy to understand, even if you've never used the Cypress API before. So here, I'm saving this CSS selector as a Cypress list. And in this example, I'm just getting that list, making sure that it has the expected starting length. So let's run these tests. So you can see Cypress will open my browser in the background. It's going to check the expected starting state, check that it can toggle to do properly, that it can filter active and complete, create new ones, and delete a to-do. And all in all, this takes about 14 seconds, which is much faster than I could do it myself. And another nice thing is that I can actually step through each of these pieces and see what the UI looks like at each step, which makes debugging really easy. So if you don't have any automated tests, I highly recommend starting with Cypress. But as long as you have some automated tests, it's better than nothing. So Cypress really makes your testing dead simple. There's no servers or anything to install. It has very readable errors and stack traces and good debugging. You can also test responsive layouts by changing the viewport size and configuring that for each test, which is really nice. And they have great documentation, so I highly recommend checking that out. This also frees up your testing team to do what they do best, which is represent your site users and try to find unexpected functionality or errors. You want to let the machines handle the boring, repetitive stuff, like checking that an email address can take a valid or invalid input. So in a typical QA suite of tests, you would have smoke tests, which are just that simple page load test that I showed, basically making sure that where there's no smoke, there's no fire. Then you also have sanity tests, which are testing more in-depth features. And then you have regression tests, which are testing the entire gamut, making sure that everything works as expected. And that's where you want to have most of your automated tests to fill in that dark circle as much as possible to get that out of the way and make things quicker. The next thing that we're going to talk about is mystery tests. I've often found that in a traditional workflow like this, you develop some code, it goes through code review. When it finally gets approved and merged into some environment, that's the point at which it goes into testing. And if there's a defect found, by the time it gets back around to the developer, the context is lost because they've already started to work on something else because of this separation between dev and QA. So I call this the throwing it over the fence workflow. The developers really don't know what's being tested because they don't have access to the tests. It's a mystery. They don't know where those tests live or how long they take to run. And the context gets lost by the time it comes back to the developer. So what you can do instead is something called shift testing left, or TDD. And that is just shifting your testing left in the development workflow closer to your development and making sure that your tests are in before anything gets merged. And this involves working with QA. It also could involve developers writing the tests themselves or a mixture of the two. And this eliminates the problem of context being lost because everything is done on the same branch or under the same feature flag, whatever your workflow is. But hold on. Isn't this approach going to take longer? How are we going to still release on schedule? People who aren't used to this sort of workflow always ask me these questions. But let's take a look at an example. And remember that we're just shifting things to the left. We're not actually taking more time. You should write those automated tests anyway because they're going to save you time in the long run. So if you just move them closer to development, you'll actually save time in the long run. So in this example, we have feature 1 and feature 2. They end up taking longer than expected. So you get into a little bit of merge hell, which leaves QA with less time to test. So they only get a certain number of fixes in before you have to do your release. So you release with some bugs, you do a second round of QA and fixes, and then you release again. If you just shift that QA left, you wouldn't be able to release with those bugs unless it's a conscious decision on your part to do so. So then you can make a better decision about what is OK to release with and what's not, and your testing is already done. And you avoid the merge conflict hell because your tests are built in before things get merged. And that brings us to our third horror story, which is unable to reproduce, AKA it works on my machine. I think we've all been there. I think this might be the worst horror story of all. So let's talk about why this happens. Sometimes it happens because the requirements are unclear or incorrect or misunderstood. Sometimes, especially if you have a large team and multiple environments, and one QA lead trying to manage all of those things, they send things to the testers to test that aren't in the right environment, so it ends up wasting their time and your time because they're trying to test something that wasn't even there to begin with. And then lastly, we have environment disparity. So dependencies, user settings, and environment-specific changes, like production versus development. So many of us that develop single-page apps, we develop locally using a node server, but we deploy static files, and we may use something like Nginx on the front end to route things or do other things. But we don't use that in our local development cycle, which creates this disparity. Because if we want to test an Nginx change, we have to install that locally and try to mirror the server environment, and that's not very easy to do. But we've actually solved two of these things with our previous workflow. So if your tests are written in the same branch or under the same feature flag as your feature, they effectively serve as the requirements. So everybody has to be on the same page, or your tests will fail. And we also solved the testing environment problem because everybody knows where the work is. But we still have this problem about environment disparity. So to solve this, we're going to dive into containers. Containers are small and lightweight compared to virtual machines. They tend to be tens of megs versus tens of gigs for a virtual machine. They're easily configurable via code, so you can see exactly what's going on. And they're open source, so you don't need to worry about licensing. So let's go back to our demo and see how we might run this in Docker itself. So here is a very simple Docker Compose file. And I'll walk you through this step by step. And this is all we need to run the site that I just showed you in Docker itself. So first, let's shut our other site down. And let's walk through this. So version 3, this is the version of Docker Compose. 3 is the latest version. And that defines some of the API that you can use below. Docker Compose is typically used to put different services together, but just for the ease of this demonstration, I'm only going to show you one service. We'll show you more later on. So we have one service, and I named it UI. You can call these whatever you'd like. We're telling it to use the Node 8 image. So Docker images, much like NPM, Docker has a registry which has image files for different languages that you can pull from. So here, I'm pulling from Node 8, and I'm telling the image to be based on that. And here, I'm doing some port mapping. So in my container, I know that my site's going to run on port 3000, and I'm going to map that to port 3333 on my machine. So I typically map it to the same port, but just for demonstration purposes, I'm going to show you it on a different port here. And then we have a mock API that's running on port 3001. Next, we're going to mount our volume into the container. So all this is doing is saying, this dot represents everything in my file system here in this folder. And we're mounting that into our app folder inside the Docker container. So we're making up this app folder. It doesn't exist. We want to put things in a different folder rather than the root of the image because we don't want to accidentally overwrite any files. And then we're going to specify some commands to run when the container starts. So we're just going to cd into our app directory, which is where all our files are going to be. we're going to run npm install, except we won't do this on conference Wi-Fi because we don't want to wait for that. And then we're going to run npm start. So let's take a look at what that looks like. To run a Docker Compose file, all you have to do is run docker compose up. By default, it will look for a file called dockercompose.yml. So here we can see that our JSON server is running in the background. That's our API. And now it's starting our development server. So do I always use Docker when I'm developing locally? No. But if I want to make changes or change a version of Node or try to run something in a language that's not installed on my machine, then I will use it. And if you have a new person start on your team and you want to get them up and running quickly, then this is a great way to do it. So we can see that in the container itself, we're running the site on port 3000. However, remember we mapped that to port 3333. And now we can see the site exactly as it was before. Does anybody know what something that the crypt keeper might have on his to-do list might be? So we can test this out. I think he might laugh maniacally. Cool, that works. Awesome. So that is just running this site exactly as we showed it. But we still have this problem about our production environment versus development. So how can we solve that? For that, let's take a look at a different Docker Compose file. So I just named this Docker Compose Nginx because that's what I'm using in production to serve up my static files. And we have two services defined here. One's called Nginx, and the other is called UI. Much like the last example, where I was pulling from Node 8, here I'm just pulling from Nginx latest. So this is pulling from the public Docker registry. And here I'm mounting two different folders as volumes into the container. So I'm mounting my build folder, which is where I know my static files are going to be once I've built them all. And I'm also mounting the Nginx config. And the Nginx config is pretty standard. All it does is reroute everything to index so that React Router can handle all the routing for us. And again, we're mounting, oops, wrong file. And we're going to map this to port 4000 so that I can access it on my local machine at port 4000. So if I wanted to run my development site and my production built site at the same time, I could do so just on different ports. So for our UI, we're going to do something a little different here. And we're going to specify a custom Docker file. So let's take a look at what that looks like. It's pretty short. We're just telling it to run Node 8. And then we're going to provide a cached layer for Node modules, because I don't want to do npm install every time I run this site. I only want to do that when something has changed in package.json, because that's typically where, if I install something new, it'll be saved there. So that's when we can rebuild the image. So all we're doing is copying our package.json into the container and running npm install. And the way that Docker works is with layers. So this first line is a layer, and each of these lines below are all layers as well. And if nothing has changed, it's smart enough to know to use the previous layers that have been cached. And then we're just going to tell it to start from the app directory to save us the problem of seeding into that directory later. And then I can just run npm run build in my UI container. You probably don't have to symlink your node modules into the parent container. Remember that we're mounting all of our files into app. However, we ran npm install in the parent folder to app. And Node will automatically look one parent directory above for node modules. However, due to some issues with Webpack and React and the way that's built, we needed to symlink here, but hopefully that issue will be fixed soon. So let's take a look at what that would look like. So in order to specify a different file for Docker Compose, you just pass the F flag, and then run up. So this is going to build our production files for us. It's also running Nginx first. And once this is all built, we can access the site with the minified production build in our browser and test that out. There we go. And notice that we're not using the mock API that I put up, so we won't see any pre-filled to-dos here. But this does use all of our minified files. So we can see that these all load as expected, and there's only a couple files there. And we can still add C active and complete just as before. So there's still one more scenario that we need to cover, which is running our tests. Because when tests fail in your CI build, and you can't recreate that locally, that's where we have the "it doesn't work on my machine" problem. So let's take a look at what that might look like. And I'll have all of these files on GitHub, and I'll show you the link at the end, so you can take a look at this later as well. So here we have two services again. One is called tests, one is called Nginx. The Nginx one that I just showed before is the same as it is here, except that we also set up a network between these two services. So I'm just specifying the network and the IP address here, the IP address that I define as the subnet down here. And I'm also setting the logging driver to none, because I only want to know the output from my test container. I don't want to see all of this output that Nginx automatically gives me. So looking at our test container, we also are specifying a custom Docker file again. That looks very much the same as what we just showed, except here we're actually stemming from the Cypress base image, which Cypress provides. And that comes installed with things like XVFB and Node for you out of the box. It does not come with Cypress installed, because they want you to be able to install the version of Cypress that's specified in your package.json. And then we're telling this test service that it depends on the Nginx service. And this can get a little tricky, because it means that it will wait for that Nginx service to start. It will not necessarily wait for all the commands to run. So it just waits for that container to start up. And we're telling it to link to the Nginx container so that it can access it at this IP address that I specified below. And then we're setting some environment variables, like CI equals true. That's one that's typically just set. We're setting our Cypress base URL to the IP address of the other service. And we're also setting Cypress video recording to false. Cypress records videos by default, but we're not going to use them here. So maybe we can shave off a second or two. And I think that's it. And then all we're doing is telling Cypress to run in this service. So let's take a look at what that looks like. And I have all of the commands in the README here, so you can reference them easily. We're also going to use exit code from and then specify the service, because typically in CI, you just want to know, did it pass or did it fail? And you can do that with the exit code from flag. So what this is going to do is going to start up Nginx. It's telling me that it's not going to log anything because I turned that off. Now it's going to create our optimized production build, which Cypress is then going to run the tests against. There we go. Now our tests are starting. And these are running the same tests that I showed you earlier. So all of this lives in one single code base, which means that it's accessible by all of developers or your testers, whoever wants to run the tests. And there we go. So 11 tests, about 15 seconds. And we can see that it exited with code 0, which means everything's good. And we're all done. So let's recap a little bit. Things that we talked about today are changing your tooling. Make sure that you have some automated tests written. If you don't have any, then Cypress is a great tool to check out. We also talked about updating your workflow to shift your testing left, and then updating your infrastructure to use things like Docker to make sure that you have environment consistency. But most importantly, you want to see eye to eye with your team. I didn't make these changes on my team overnight. It took a little while to get up to speed with everything, but hopefully the code that I've showed today and that I'll share afterwards helps you do it a little faster. But you want to make sure that you write some automated tests, make them available to everyone, and then keep your testing as close to development as possible. Use Docker for environment parity, and then really do what works for your team. Adjust and fit these in as needed. You don't have to do them in the sequence that I showed. So just do what works for your team. Thank you very much. Here's where you can find the code. And if you're interested in learning more about Elsevier, please find me after the talk.